Hey all, good afternoon. This is Yashas, introducing you guys Nacre Mimicking Composites along with my friends Camille, Renald, and Lingeshwaram. First, I'll give introduction on what nacre is, how it occurs in the nature, how we can mimic the structure and composition using the available processing techniques, the mechanical properties, and application for the same. Mankind has always been looking for new materials for better mechanical properties and has always been trying to create structures which are beyond speculation. From past few decades, the art of mimicking nature in terms of structure and materials has been in focus for major part of young fellow researchers. Biomimicry is one good way of developing and improvising design both in terms of physical and chemical aspect of a product design. This is nacre, also called as mother of pearl, which is the exoskeleton created by the mollusk, and also the pearl, which is also created when an intruder enters the mollusk skeleton, creating an agitation which causes an entrapment secretion around the intruder. When scientists researched for its extremely well strength to weight ratio, it was understood that the layer by layer arrangement of aragonite bound by polymer is the reason for it. Scientists have come up with several processing methodologies to mimic nacre-like composites. Diel-Salter polymerization with bidirectional freeze casting is one such method, where aluminum slurry is introduced into mold and bidirectionally freeze casted to obtain a mechanical scaffold. The scaffold is then pressed and calcinated to densify it to obtain a smart nacre. Brick and mortar arrangement is one another method where brick forms the rigid part and mortar forms the polymer soft part. Layer by layer arrangement is one another method where rigid part and soft part are arranged layer by layer to obtain a 3D bulk structure. Powder sintering is one another method where metal alloys can be powder sintered to obtain nacre-like structure, which has been successfully created to form implants. One-step wet spinning is one another method where 1D fibers can be created, where graphene oxide fibers have been wet spun in order to obtain nacre-like structure. But this structure will be of very rough surface which causes self-abrasion to damage it. So it is introduced into a water-based solution of graphene oxide and then it is made smooth so as to obtain a smooth 1D fiber.
Hey y'all, I'm going to talk about a material which is nature's gift. Yes, it is nacre. Nacre is also known as mother of pearls. It's present in inner shell layer of mollusk. The material is very smooth and available in different colors like white, blue, even sometimes peacock color. So it is iridescent, and it is very shiny material. By zooming this nacre, we will get a brick structure. It is calcium carbonate. More than 95% of nacre is composed of organite, nothing but calcium carbonate in the orthorhombic structure. These bricks are together by a glue, that is biopolymer. A biopolymer is glued in between the organite bricks, which are sticking like polysaccharides and some proteins, which are acidic and basic nature. Many scientists have been mimicking the nacre in a different composition and a different material. In that, we have taken a three composition. Our first composition is polyacrylic acid and polypropylenyl in a layer by layer method. Our second composition is alumina matrix in a diel network polymerization. Our third composition is wet spinning of graphene oxide in 3000 bath. We have a specific reason to take these three compositions. Yes, a polyacrylic acid and a polypropylenyl pyridine in a layer-by-layer method will take a lower energy to produce or in manufacturing sector. In the special case in PAA and PVP is PAA is a water-soluble polymer and the PVP is a super absorbent polymer where it has a wider range application. In our second composition, the aluminum matrix. Yes, organite is an unstable compound. When it is in a higher temperature, it changes to calcite. That means it will lose the Nacre property. So, for higher temperature circumstances, this aluminum matrix will be useful. Our third composition is with graphene oxide. The graphene usage of graphene oxide is tremendously increasing the electrical property of the material, where the material achieving mechanical and electrical property.
As Lingesh just explained, various compositions can be used to form nacre-like composites. These changes affect some properties of the product. It can enhance its thermal and electrical conductivities and develop some interesting characteristics, such as fire shielding. The use of biodegradable materials is also interesting in order to make these composites sustainable and therefore a great alternative to petroleum-based plastics. However, the composition of Nacre-inspired composites plays a small part in their most interesting properties. They have a high fracture toughness and strength. Indeed, Nacre's outstanding mechanical properties result primarily from its intricate brick-and-mortar architecture. It generates a lot of interfaces interactions at different scales, which hinder the propagation of cracks. Nacre-inspired composites are also light. All these properties allow a wide range of applications for these materials that Renald will now review.
Camille had explained the various properties of nacre-like composites. I will be explaining the applications of it. Nacre-like composites are being inspired in several materials such as electric cables, fire-retardant materials, gas barrier materials, nanogenerators, supercapacitors, and engineering materials. This is due to its high macroscopic and mechanical properties, thereby which it can be used as an alternative for plastics and alloys. The mechanical properties are high within these composites because of its lattice arrangements, which can be further divided into 1D, 2D, and 3D. 1D Nacre composites. These are most widely used for making clothes, for twisting into ropes to transfer mechanical load, and for conducting electricity to transfer electric power. These possess much higher strength and toughness when compared to traditional fibers. 2D Nacre composites. These are most commonly used for manufacturing paper, constructional applications, and for flexible devices. On the other hand, 2D Nacre composites exhibit low mechanical properties, therefore it cannot be used or it's not advisable to be used on heavy applications. 3D Nacre composites exhibit much higher strength and mechanical properties when compared to 2D and 1D, therefore in which it can be used for constructional and for making furnitures. In addition, these composites also exhibit high flame resistance and are structurally stable during flame. This is due to the formation of interconnected and compact car after combustion, which can be applied as protective coating to combustible materials. The strategies for further improvising the mechanical properties of Nacre Inspired Composites involve complications but are in a great demand. Limitations observed in the so far produced Nacre-like materials is thermal compensation as a result to achieve self-healing properties or toughness to overcome the brittleness. Even though a certain number of polymer matrices have failed to give better thermal properties, metal alloying can be a substitute for drawbacks. The results obtained from self-healing properties upon thermal processing is proven by scratch healing experiment conducted by same fellow researchers. Thank you.